and welcome to the history of the Metacrisis. Today I have the great pleasure of hosting a spaceman, literally a spaceman, Mr. Stephane Ourevitch, who is a notable figure in the field of space data applications, particularly related to Copernicus. Stephane is his professional background. He holds an MBA degree from INSEAD and a master's degree in law and political science, international affairs from Sciences Po. He has over 30 years of professional experience, and he is a founding partner at Also Space. Without further ado, let's discuss with him about his background. Stephane, welcome to the history of the Metacrisis.
Hello. Pleased to be here.
I'm pleased to have you. Please tell us a little bit about your past and how you got involved with space. This is such an interesting and such vast field, and especially with Copernicus.
I didn't really get involved with space. I got involved with Copernicus. I was in between two jobs. I used to work in industry and in senior management roles. And a friend of mine said to me, you know, there's this project funded by the commission. It's about space. It's all high tech. It's all in English. Could you help me set it up? And I'm like, what is it about? Well, it's this thing. At the time, it was called GMES for Global Monitoring of Environment and Security, which is the previous name of Copernicus. It was about starting to do what we call user uptake. So it's basically finding users, bringing users to the data and to the applications and information products. And this was supposed to last maybe 1 month or two just to help them start the project. And I must say, I fell in love with what was not yet called Copernicus. And this was 18 years ago. And for the past 18 years, I've been working in trying to make sure that the data, the information is used to the widest possible extent, and that it becomes known that this is really one of the areas where the European Union has done things that couldn't exist and couldn't be done without it. It's like there are few examples that really can speak to citizens. If it's all about regulations and things like that, it's unclear. If you say to people, if you roam from Greece to Croatia, you don't pay. You used to pay, and you used to pay hefty prices. That's interesting. For the citizens, if you say to citizens, when there was a fire last year in Greece that burned 80,000 hectares, every day Copernicus was delivering images to the Hellenic fire service and to the Hellenic civil protection. Then they started saying, Europe's doing interesting things.
Yes, actually, Copernicus is one of the biggest examples of European unification process, one of the positive workings of the Union, and one that is delivering concrete results every day. Actually, this week, Copernicus published a report concerning climate change in Europe, which is quite heartbreaking, I would say. The data are not to be questioned. The data are specifically straightforward. They talk about 2.6 degrees above pre-industrial average, 1.2 deviation from average, second warmest year ever recorded in Europe. How do you feel? How does that make you feel about that?
Well,
your findings, everyday workings.
It was many, many years ago that late former French President Jacques Chirac said, our house is burning. More recently, both Mr. Gutierrez from United Nations and President von der Leyen also used very strong words. Our world is on fire. Our world is burning. And with so many climate deniers, with so many people not really worried about A, the reality of the situation, and B, what they can possibly do at the individual level to help make things at least maybe not better, but to avoid that they worsen further, I think that the fact that this is based on world-class science, unquestionable, makes a difference and strongly participates to raising awareness. One thing is raising awareness, but then thanks to Copernicus, and I'll try to explain why and how, it also, Copernicus also brings information that can be used to mitigate climate change consequences, to adapt to the consequences and the impact of climate change, etc., etc.
So I know that you have prepared the presentation for us. Would you like
Yes.
to go us through so we can discuss concretely about the workings of Copernicus?
Yes, I have prepared a presentation because, let's see, I hope this one's the good one. Hopefully, yes. Share. No, it's not. It was the other one. So, do you see my screen?
Yes, I
Okay.
can see your screen.
So, I need a presentation because Copernicus is a very complex animal that has many arms, many legs, many even heads in some sense, although, well, there's one head, it's the European Commission, which manages the program. But for your information, Copernicus is part of the EU space program. The EU space program has three main areas of activity: Earth observation, and that's Copernicus, I'll come back to it; navigation, that's Galileo; it has protected and secure communications, and it has systems to help manage space traffic management and all the debris that we have in orbit that are causing potential problems. And going back to navigation, Galileo, I'm jealous of my colleagues responsible for outreach and user uptake for Galileo because it's very easy to explain to a 5-year-old. It's the thing everybody understands. It's the thing that powers the screen, the navigation screen on the phone or in the car. While Copernicus, I need 20 minutes at least to make sure that you can have some idea of why did the European Union launch this project, this program, and what are its many benefits. In fact, when I started 18 years ago, my first colleague in the field says, your challenge is help me explain Copernicus to my mother. She has several master's degrees. She's an educated lady, but not in science, not in remote sensing, not in space. So help me explain that to her. So this is what I will try to do now. So Copernicus, we found a punchline, which is Europe's eyes on Earth. And it's not eyes on Earth in the sense of Big Brother that would be looking at European citizens. We cannot see with our satellites any object that is smaller than 10 meters. So we don't see people. We cannot count people outside of a supermarket or queuing in front of a monument. There are satellites that can do that, but these are private or governmental satellites. They're not Copernicus. So in a nutshell, what is Copernicus? It's one of those flagship of the European Union. Again, like roaming, like a common social laws, like a common agricultural policy that helps so many farmers to have a sustainable future in the Union. It's basically a system that was developed, a systems of systems even, that was developed to help monitor the Earth, its environment, its ecosystems, helps to look at biodiversity, to prepare and respond to crises, to security risks, to disasters. The most important thing, and I'll come back to it, is the data policy is, we call it full, free, and open access. It means any business, any citizen, any journalist, any startup, any entrepreneur can use this data without asking for permission, without having to register, without having to declare what he's doing or she's doing with the data. They can just use it. For entrepreneurs, for instance, it's a bit as if the European Union was sponsoring people who want to create a transportation company by providing them with free fuel. In fact, some people say data is the new fuel. And in fact, it's powering so many applications. I'll give you one example. When people look at their mobile phone at an app that tells them if they're allergic to pollen, whether there's a risk for them, not today, tomorrow, the day after, 4 days ahead, that data, in fact, comes from Copernicus, and somebody is making you pay €2 per month or whatever for the app on Android or on Apple systems. You pay €2. The entrepreneur hopefully makes some money, but he's using free and open data that is accessible under no conditions other than citing the origin of the data. So European Union. This is paid for by the budget of the Union in a large majority of the cases. And that's really the game changer. In the past, satellite data, space data was very expensive. So nobody can use it other than the military and some applications with clients that have a lot of money. The oil and gas industry, for instance, but they would use satellite data according to the state of the market. If the market was on an upwards trend, they would use it a lot. And then if all of a sudden the price of the barrel of oil went down, they would use it less because it's a very costly commercial imagery, is very expensive. Last but not least, Copernicus is turning to be a tool for economic development because there are many startups, scale-ups, SMEs that have been born or have thrived thanks to the use of this basically baseline information that is completely free and easily accessible. It all started 25 years ago when the European Commission gathered a meeting of representatives of European space agencies in a place around the lake in northern Italy called Baveno. And in Baveno, they signed, it's north of Milano, they signed a manifesto calling for the creation of this global monitoring for environment and security program, which was finally adopted as a official program, funded, and eventually was renamed into Copernicus because there was Galileo and GMES. Commission said maybe it's better to have astronomers' names for each one of the components of our space program, so they called it Copernicus. There's been a whole history over the past, but just to say it took 25 years, you might think it's a lot of time, 25 years, but you have to collect the user requirements. You have to turn them into specification for satellites or for services. You have to build the satellites. You have to launch the satellites. This takes a lot of time, obviously. And 25 years might sound like a long period of time, but in reality, look around. NASA doesn't have anything equivalent in the United States. China doesn't have anything equivalent. Japan, I mean, only Europe has a comprehensive. In fact, people refer often to Copernicus as the gold standard in Earth observation, in space-based Earth observation, and this is really indeed the case. Copernicus is customer, or I would rather say user-driven. In fact, it all started by collecting user requirements. What is it that the Ministry of Agriculture of Germany needs? What it is that the Greek Civil Protection need? What it is that the French Fisheries Agency need? What is it? So member states' needs and European Director Generals, like the Director General for Environment, for Maritime Affairs and Fisheries, for Civil Protection, all these requirements, these user needs were collected, and they were transformed in the satellites should do this, this, and that. Why did we have to build satellites? Well, because there was nothing commercial available. Sometimes because there's no market. If you want to build a satellite to measure sea level rise and look at the consequences of climate change, which is the private market that can pay for that? No one. It's obviously a public good, and it has to be built by governments, but no government is rich enough or maybe structured enough to carry out such a program, and therefore it was done by Europe.
So in a sense, Copernicus is actually the opposite of the tragedy of the commons.
Yes. Yes, because in this case, it was really, and it's still the case, several of the Copernicus services we didn't think about them in the beginning. They were not in the first services that were deployed. It's the member states that said, we believe that with satellites and models, you can do this particular application. It's clearly in the remit of Copernicus. It's linked to the environment or to security of citizens or member states. And the new service was developed, specified, and then contracted to industry, and it's now operational. So there is no end to the process. It all depends on the capabilities of the satellites. But basically, Copernicus is built on several pillars. One pillar is the space pillar. So the satellites, which are called Sentinel satellites, I'll come back to it, and which again were built to fill the gap that France, the big space powers at the time, you have to think 25 years back. Now, Greece has a space program, Italy has a space program, but 25 years back, only France, Germany were launching regularly satellites, etc. So there was a gap, and this gap is being filled by those Sentinel satellites. Then there's what we call the in situ data, on site. One, you need real ground truth data to verify that the measurements of your satellite are good, are correct. If the satellite tells you that over Athens there is 2 micrograms of sulfur dioxide by cubic meter, how do you verify that it's true? Well, by having a sensor on the ground that tells you a number, and you can correlate that number. So you can validate and calibrate the sensors, the instruments on board your satellites with in situ data. Second use for in situ, there are things which you cannot measure with a satellite. Look at the temperature of the sea. You can measure the temperature on the surface, but you cannot measure the temperature below the surface with a satellite. And you need that information for climate studies, for the Gulf Stream, because what happens at minus 500 or minus 1,000 meters under sea level is currents that influences the Earth dynamics and the climate. These, the space component is managed under delegation, so basically the European Commission has delegated the design, the production, and the launch and operations of the satellites to the European Space Agency, ESA, and to the European Agency for the Exploitation of Meteorological Satellites, EUMETSAT, while the in situ data is managed by the European Environment Agency. So that's one pillar, the data pillar. Then you've got services, 6 types of services. I'll come back to it, but a marine service, an atmosphere service, an emergency management service, a land monitoring service, a climate change service, and a security service. These services use the data from the space and in situ component. In some cases, they run the data through models in order to produce forecasts and analyses, and that information can be used by is used by users such as the Environment Agency of Italy or government bodies, managers of biodiversity preservation sites, etc. But it's also used by private industry and entrepreneurs to produce what we call downstream services. That's the Copernicus economy. And these can use either the outputs of the service. Again, to go back to the example of the app in your phone with alerts for pollen allergy sufferers, this app is powered by the information from the atmosphere monitoring service of Copernicus, while other types of applications are directly powered by the satellite data. That's the arrow you see in the below part of this schematic. So the Sentinel satellites, the Copernicus Sentinel satellites, 6 different types of satellites, 7 actual satellites in flight today, but the number is going to grow to over 20 in the next 5 to 6 years. One is called Sentinel-1. Sentinel-1 is a radar. So radar is great because it sees at night. It sees through clouds, because if you try to make a picture of an area on Earth that is covered by clouds, you'll have a completely white picture. So no information. The radar will see through clouds, will see at night, and will, for instance, easily distinguish oil after an oil spill from water, or water from bare soil in case of floods. So it's a very useful tool. Sentinel-2 is an optical. It's like a camera, but it's a camera with 12 different. We call them spectral bands, but it's a bit like, we all know that a fly doesn't see the same thing as a cow, who doesn't see the same things as a horse, that do not see the same things as a human being. So it's basically 12 different sensors that all see in a different wavelength, a different type of information. And this, when you combine this information, you can extract data about the health of plants, about the presence of water, about the humidity of the soil, about burnt areas after a wildfire, etc. Sentinel-3, so the first two, Sentinel-1 and Sentinel-2, they on average pass every 5 days on top of every place on Earth, with the exception of the poles because of their orbit. Sentinel-3 sees a wider area, comes every day, but has a lower resolution. The first two satellites, Sentinel-1, Sentinel-2, they have 10-meter resolution. Sentinel-3, you're talking 100 meters. Sentinel-5 is a satellite dedicated to measurements of the atmosphere composition, so pollutants, aerosols, such as, for instance, sarin dust, which can easily be measured, while Sentinel-6 is an altimeter, so it basically measures the height of the sea, which is increasing under the effect of sea level rise and climate change. Then we have so-called expansion missions. These are 6 new types of satellites that will be launched starting in 2026 and up to 2032, I believe. That will help better monitoring of the Arctic, better monitoring of agriculture, deforestation, growth, etc., etc. And last but not least, that's the satellite called CO2M on the lower left side of this slide, which is going to help to monitor the application of the Paris agreements on climate change, as it's a satellite family that enables to detect with high precision, high accuracy, the origin and the magnitude of anthropogenic, so caused by man, CO2 emissions. As you can see, the first launches were in 2014. We recently celebrated the 10th anniversary of our first satellite, Sentinel-1A. They were specified in the beginning to last for 7 years. So it's already interesting to note that they're lasting significantly longer, nearly 50% at least, in the case of that first Sentinel-1A. And the other interesting information you get from this chart is the supply of data is guaranteed for at least the next 15 to 20 years. And that makes a big difference. Nobody is going to change its operations flow, fire brigades, emergency management agencies, agricultural agencies, whatever. They're not going to change the way they work because some experimental scientific satellite has been launched and is providing data, because we all know there's no guarantee that the successor will be launched. There's no guarantee that this satellite has a substitute that can be launched in case it has a technical problem. So another big change of Copernicus vis-a-vis other types of previous missions is not only is the data completely free, but its availability is guaranteed over time. So it enables companies, governments to basically start using this data with a guarantee of having it available for a certain amount of time, a significant amount of time. So a few examples to make you understand the benefits of these Sentinel satellites. Sentinel-1 with its radar will detect oil slicks. So oil slicks, some of them we know because the boat has had an accident and therefore it's releasing petrol into the sea. But there's a lot of also illegal cleaning of the tankers by some not very nice captains, and this can be detected because the reflection of the oil is different from the reflection of water when seen by the radar. This is an example late last year of an oil slick in the Gulf of Oman. You can also easily detect ships.
Have you shared the picture with us? Because I haven't. I only see the first slide of your presentation.
You only see the first slide of my presentation?
Yes.
Oh. Well, normally I'm sharing my screen.
It's not moving. Has it been moving?
Yes, it has been moving.
Oh.
Let me go back and see what I can change here, if I can.
Oh, I'm so sorry. Maybe you can make it full screen or something, because now we can only see the first slide.
It was full screen. I was seeing it full screen. Maybe I'm sharing the wrong screen. So let me just close this so there is no risk. And let me share this. Now this is still this, but if I close it, I have an issue that I also close our wave. So now let's try. Technical. The thing is, it doesn't offer me anything to share. Oh yeah, this, maybe. Can you see it now?
Yes.
Okay.
Now it is excellent.
So this is the first visual example, so the rest wasn't too necessary. So here you see clearly with that black spot here, this is oil. This is oil, and this is detected by the satellite. And you can have automatic processing. It can be sent to receiving stations within very short amounts of time, and it helps to catch, not to catch illegal cleaning activities at sea. And it also serves to start models that can predict where the oil is going to go after some time.
And practically, so sorry to stop you here, Stefan. When you get this image from the satellite, what is the process? What happens afterwards? Do you get the signal and an alert with it, and then you have to notify, I don't know, the police, the member state who is responsible? How does that work?
Well, in fact, there is a service. Operated by the European Maritime Safety Agency based in Lisbon that acquires from Copernicus and also from private satellite operators satellite data and automatically produces within very short amount of time an alert that is sent. Let's say in the Gulf of Finland, an oil slick is detected. The Finnish border guards or the Finnish Coast Guard, depending on which is the agency responsible, will be immediately notified. So there is a notification of so-called authorized users. And the Marine Service of Copernicus will also supply models that can predict, depending on the currents, on the wind, and on the type of oil, where possibly this oil is going to drift, and which beaches, which areas, protected areas in some cases, will be affected.
Good.
This is another example of the radar vision of Sentinel-1. Here we have basically aggregated images over a long period of time, and you can clearly see the shipping lanes across the Strait of Gibraltar, which means you can detect a ship even under a cloud cover, and the Copernicus Maritime Surveillance Service also helps customs, border guards, police, etc., track ships that switch off their transponders, because when you see no ship reported by transponder, but you see a radar image, a ship on the sea, you know that ship has turned off its transponder, and you can therefore suspect that he's got something to hide. A few images from Sentinel-2, the cameraman or the photographer of Copernicus, which again passes every 5 days above any point on the globe. Here you can see examples, for instance, of images of the recent volcanic eruption in the Reykjanes Peninsula in Iceland. The image on the right with the red dot, this, I was talking about these 12 different pairs of eyes. Here, why do you see this red? You see this red because the satellite has one of the eyes is infrared, so it sees heat sources. So you can detect certain things, fires, lava. That's a lava flow. What you see in red right now is the lava flow. So in some countries, maybe you would say in Iceland, we don't need it because it's not a super remote area. There's helicopters from the police, but in some areas, remote ones, it can be an extremely useful tool. Other examples, to monitor droughts. Here on the left, you see Lake Mead in the United States. You can see how much the water has receded because of the drought. On the right side, you can see a huge wildfire in Siberia, extremely remote areas, and therefore there are no drones flying all the time, helicopters, watchtowers, etc. And with the satellite, well, you can obviously detect these fires and easily measure what we call the burn scar, so the area that was actually burnt by the fire. And in this case, it's sometimes the size of a city like as big as Athens that can be burned. You can also monitor ecosystems, both inland and at sea. Here's a very beautiful image of the Great Barrier Reef in Australia. You can, with Sentinel-3, you can monitor, for instance, dust clouds. You had one recently over the Eastern Mediterranean. Well, this image was taken on the 28th of March and shows the Saharan dust cloud over the Mediterranean, over Sicily, over southern Italy, over Malta, etc. The Sentinel-3 can also provide interesting information to meteorologists when there are storms. This is another recent image. SEL5P, the atmosphere monitoring, it monitors trace gases like nitrogen dioxide, sulfur dioxide, carbon monoxide. It also monitors methane and aerosol dust, ashes, etc. On this one, you can easily see the shipping lanes. What you see here at the bottom, you see the shipping lanes going from
Italy to Greece.
You can really see them around here along the way to the Suez Canal, and then going down here the south of India to Japan. So you can really see the main sources of pollution. China, obviously, the Ruhr Basin and western Belgium. This is Moscow. This here, I believe, is the Po basin in northern Italy, because the Alps are blocking the evacuation of pollution. They act as a barrier. So this is a tool used daily to provide information for alerting on air quality and forecasting air quality, because it provides the input information. That's another example. This is the methane distribution in the world. And Sentinel-6, as I said, measures the sea level, and this is a map where you can see some areas that are rising, but in fact, some areas in blue are also decreasing. So it's a mixed phenomenon, but the reality from the bright colors, the bright reddish colors, the reality is there and clearly shows sea level rise and provides us with long time series to monitor the phenomenon over time, because SEL6 is a successor of a family of satellites that has been making such measurements for the past 20 years.
And we also see here to the previous screen, we also see that is it Lake Baikal that is residing too much?
Yes, I guess that's what you also see. Then the 6 services. The Copernicus Security Service, I cannot talk too much about, because that's the exception to the rule of Copernicus data is free and open. These services, because they address governmental needs for security, for borders, for crime management, for illegal activities, or for the protection of EU assets outside of Europe, during peacekeeping operations or in areas where EU citizens are in danger because of civil war or other types of events. This data is reserved to what we call authorized users, and the data is usually classified and not made available to the public. But so 6 lines of services. The land monitoring service has global products that enable to look at the vegetation and deforestation in particular, but also provide information about the solar radiation, the wind, the level of the lakes, the rivers, the status of the snow, the glaciers, etc. There are pan-European products that for the 38 member states of the European Environment Agency, so that's Europe, EU, plus Balkans, and all the way to Turkey, provides information about the land cover. What is the land used for? Is it city? Is it industrial parks? Is it forest? Is it crops? Is it abandoned land, etc.? High resolution layers that are used mainly for the protection of biodiversity. And many Natura 2000 protected sites in Europe are monitored by the Copernicus Land Monitoring Service. We also have an European ground movement service that uses Sentinel-1 because with the radar you can measure over time millimetric displacements of the terrain, either vertically, so that some cities are sinking because the aquifer, for instance, is depleting. Other areas are moving laterally because of small landslides that can turn into really dangerous, geohazards. That is, for instance, a service that did not exist in the beginning, was requested by member states, and the Sentinel-1 satellite data made it possible. And then some local data about cities, what we call the urban atlas, that defines in high resolution what is the land used for in cities. Riparian zones, these are the zones along the rivers, where obviously there's a lot of biodiversity, and the Natura 2000 protected sites. This is used in all kinds of applications: forestry, agriculture, management of natural resources, etc., etc. A few examples. This is, for instance, the land use in a Natura 2000 protected area in the Biesbosch National Park in the Netherlands. That's another example that's looking at deforested areas in Mato Grosso state in Brazil. And in fact, we are about to release a new product that will monitor on a yearly basis, globally, worldwide, will help monitor deforestation. For obviously conservation, but also to help apply the new EU regulation that says that all companies or countries exporting into the EU commodities such as coffee, soya, rubber, etc., must certify and prove it does not come from an area that has been recently deforested. The Marine Service measures sea level, the salinity, the temperature, the currents, the winds, what we call the ocean color, which is the amount of phytoplankton, the amount of suspended sediment, etc. And finally looks at sea ice, the extent and the thickness of the sea ice, which is an important parameter not only for navigation, but also to monitor the consequences of the climate change.
Sea ice of the Arctic or also of the Antarctic?
Globally. In both cases, the extent and thickness of sea ice is measured by the Copernicus Marine Service and reported. So the applications go from aquaculture to marine renewable energies, because you can use currents, for instance, to produce energy with underwater turbines, maritime safety, transport. For instance, you see a tanker, and you're Greek, so Greece has always been a very maritime country. Some of the major shipping companies in the world are using Copernicus Marine Service ocean current data to optimize the routing of their ships, to follow the current, basically. And this is producing savings around 3 to 5% of their fuel bill. You may think, 3 to 5%, that's very small. But you're talking 3 to 5% of hundreds of millions of euros that are saved.
And also of pollutants.
Exactly. And I was about to say, as shipping is a very polluting activity because they use a poor quality diesel fuel that is very rich in sulfur, so produces a lot of sulfur dioxide. It also reduces, by definition, if they use their engine less, they pollute much less. This is an example, for instance, it's the anomaly in the sea surface temperature in the Mediterranean basin, and you can see in early April, in some areas around Greece, at the bottom of the Adriatic, the anomaly was above 5 degrees. Our seas are warming, It's having an impact on biodiversity. In fact, globally, corals, we're facing one of the four biggest coral bleaching events in the history, in the recent history at least. And this is clearly caused by marine heat waves and the global warming of the oceans.
So we're not talking actually about warming, we're talking about boiling.
In this case, well, it doesn't physically boil, but it's warm enough so that some species cannot survive or cannot survive with the same quantities, which is a major thing. This just illustrates the fact that the Marine Service also looks at currents. You can see this. It's lovely, but it's useful. This is the Gulf Stream. And as the Gulf Stream is a regulator of the climate and the weather in Europe, monitoring that current is of importance for medium-term climate and weather forecasts. The Copernicus Atmosphere Monitoring Service. This measures atmospheric quality and composition. So what is the quantity of a certain pollutant? What is the quantity of ashes or Saharan dust or whatever in the air? Looks at climate variables, the greenhouse gases, the ozone layer. There are some very nice animations of Copernicus that show how the ozone layer evolves in a year. UV, so this direct impact for citizens. There are apps where you enter your skin type. The app knows your location because your phone has a Galileo, hopefully, and maybe also a GPS receiver in it. You will receive automatic warnings saying tomorrow you should put SPF 50 sun cream because we're expecting a level of UV radiation of whatever. This is another type of app directly benefiting citizens, which is powered by Copernicus. It's also useful that solar radiation information for people wanting to set up solar farms. You can look at the past. How much sun is this area receiving? So it helps you to define whether your solar farm or your solar roof. There's an application, at least in French and in France, called My Solar Roof, where you can estimate how good is your location for the production of electricity with photovoltaic roof panels. So it's useful for developers. It's also useful for companies and developers. And this obviously has applications for health, for monitoring of the environment, of the pollution, for climate studies, and for renewable energy. A few examples here. This animation shows the particles that are, these are large particles, PM10, how they're moving from the Sahara. And we not only measure how they behave, but the service, because it has models that are nourished by years of previous data, this can tell you what is going to be the situation in 4 to 5 days. So that makes also a major difference. The same thing exists for pollen, and it's obviously useful for pollen sufferers, allergy sufferers, to know that tomorrow there will be a big peak in, let's say, olive tree pollen to which they are particularly allergic. There's a big peak tomorrow, so they will either not go out or go out and take more antihistaminic medicine or whatever. So this, again, direct impact on the citizens. Here, this is a visualization of our nitrogen dioxide product. And there again, you can clearly see the shipping lanes going through the channel between England and Western Europe, along the Spanish coast, the Gibraltar, Detroit, along the coast of North Africa, south of Sicily, all the way to the entrance of the Suez Canal. And then you can also see the sources of industrial pollution in Germany, in the Ruhr Valley, around Amsterdam and Antwerp, on the western coast of the Netherlands and Belgium, and the Po Valley, which I was mentioning earlier. The Climate Change Service produces all kinds of what we call essential climate variables. These are the variables that the IPCC, these scientists that work for the United Nations and produce regular reports, they feed their reports with information coming from the Climate Change Service. It also provides support to mitigation and adaptation strategies. Actors such as Heineken are using Climate Change Service data, and I'm making no publicity for any particular beer manufacturer, but that's just one of the use cases I remember. They're using it to try and figure out what the impact of climate change will be in the production and availability of the raw material, water, yeast, etc., that they need to make beer. The same, there is a service for tourism that helps ski resorts try to model and understand what will be the potential impact of lack of snow or reduced amount of snow in the future. And the service also produces forecasts, seasonal forecasts into the future and climate projections. Many of your listeners and auditors may hear or on the radio, on TV, or read in their national local newspaper, Europe, second warmest year in history, or second or warmest November on record, etc. This information in all cases comes from the Climate Change Service European State of the Climate for Europe. This European State of the Climate was published on Monday morning of this week, and amongst many other highlights and key findings, tells us, as you were mentioning, that 2023 was indeed the second warmest year on record for Europe. And with above average, we're more than 1 degree above average. That gives you an idea of the magnitude and severity of the climate crisis. Also, you look at fire danger, another thing that is reported, and you can see that in Spain, in southern Italy, in Sicily, in Greece, in Turkey, there is a very strong increase in the fire danger compared to previous years. And burnt areas are also higher than ever. In fact, our Greek auditors will certainly know that a fire last year in Greece burned over 80,000 hectares and was the largest fire recorded in the EU since the 80s, since we actually have a record that is systematic and accurate. They also work a lot on providing information to the renewable energy sector for past information, again, to be able to figure out what is the potential production of a facility in a certain particular geographical location, and to also look into the future. Last but not least, the Copernicus Emergency Management Service that provides both early warning. There's a thing, for instance, called the European Forest Fire Information Service, which every day and for the next, I think, 14 days, provides information about how likely are forest fires in a particular area based on the level of dryness and drought of the area, the type of fuel, the type of trees, on the wind forecast, etc. And this is widely used. This is one of the Copernicus products most looked at in terms of numbers of visits to the website, because local fire brigades, media, citizens look at this regularly during the wildfire season, which is these days the starting earlier than ever and finishing later than ever. So also we have a European and a global drought observatory and a global and European flood awareness system that provides warnings in the case of forecasted floods. Then it also does mapping, risk and recovery mapping. This is basically trying, before any disaster happens, to prepare plans, evacuation plans, to evaluate where are the camping sites, public areas, parking, roads that could be affected in case of earthquake, in case of landslide, in case of volcanic eruption, in case of flash floods, in case of whatever. And in fact, the Greek government activated that service to do an assessment of the risks and the vulnerability for the antique sites of Olympia and Delphias, and we produced tens of maps that are being used to make sure that a camping site is not authorized in an area that would be really one of the most exposed in case of, let's say, floods or wildfire. So these are really operational products, again, having an impact on the security of European citizens. And in this particular case, and this example I was giving, cultural heritage also can be better protected in the face of the rising number and intensity of disasters that are fueled to some extent by climate change. The other products are called rapid mapping, and this is using satellites to produce maps for emergency services within hours of the acquisition of the image by satellites. This is used a lot by Spain. Last year, I think in the midst of the wildfire crisis, we had maybe 15 activations in parallel. We were looking at 15 different wildfires, some in Greece, some in Italy, some in Spain, some in Portugal, some in France. So this is also one of those services which has direct impact on saving lives and saving property in the face of disasters. Here you have a little map of the number of activations of 2023. And as you can see from the map on the left, this is global. We're activated for wildfires in Chile. We're activated for floods in the Philippines, but we're also activated everywhere in Europe for volcanic eruptions, floods, in any type of disastrous event. Our Global Drought Observatory looks at the situation in some very badly affected areas such as Southern and Eastern Africa. They also, as I mentioned earlier, this is an example from, I think, yesterday or the day before, 23rd. This is the fire danger in Europe and North Africa for a particular day. But if you go to EFIS today, you'll see the situation for tomorrow and for in 10 days. We've also launched thematic hubs to try and group the information relevant for a certain economic sector or particular thematic area in one place. So you don't have to look at some information in the Climate Change Service portal, some in the Land Monitoring Service portal. So these now exist for energy, for health, for the Arctic, and for coastal areas. So trying to have a one-stop shop for all the Copernicus information about one thematic area. Copernicus, interestingly, has become a very important source of information for the media. Documented events in the news. The image you see here on the right, this is land surface temperature, so the actual temperature of the ground. It's not the thermometer. This is how warm is the ground. This is the ground in Siberia in 2020. And there were lots of wildfires at the time because there was a big heat wave. Well, this image was reused in 13,000 media outlets worldwide, from the Asahi Shimbun in Japan to the Washington Post in America to Die Zeit in Germany, Le Monde in French. So we play with Copernicus a role in raising awareness of climate change, and media helps us also to substantiate the benefits of Copernicus. And here are a few examples. You see CNN, the World Meteorological Information Organization, Reuters, all kinds of magazines all over the world that are reusing our data in the UK, again on CNN. So, and all kinds of different themes: droughts, temperature, heat waves, wildfires, climate evolution. One of my last points is, because this data is all open, we, the Commission, have put together a data access system that is simple to use, that does not require a PhD in space technology or remote sensing or geography, where anyone can go. You can basically go and look at your own, the area where you live, using that system. It's called the Copernicus Data Space Ecosystem. You just have to Google it. You'll find it really easy. It has, you can see it on the left side, a very, very user-friendly interface where you can just decide, I want to see all the images without cloud. I want to see the images from this period to this period. And then you can use special filters to use these 12 pairs of eyes I was talking about earlier to see either the burn scar from a fire or anything else. And as you can see, it's working pretty well. We have 150,000 registered users, nearly 400,000 visitors for this what we call the browser, which is the system that enables you to visualize the information. And there is all the data archived since 2014. Every image acquired by a Copernicus satellite can be found there, analyzed and processed in the cloud, and downloaded freely. There's only limit is how much you use the system. If you use it a bit too much, it means you're a company, not an individual, and then you would have to pay a fee. But for citizens in normal use, it's completely free. I'm here as the representative of the EU Space Support Office, which is an organization funded by the European Commission, and which is there to support users, researchers, media, but also citizens in asking any question that they would have about the EU space program in general and Copernicus in particular. We also animate the so-called EU space networks, which has our 115 Copernicus relays and 233 members of the Copernicus Academy. These are university. Like, again, to take an example, in Greece, I think we have 15 members in Greece. We have, as you can see from the map, 42 or 43 members in South America. So it's not only a European thing, it's really a global thing. So this is basically the end of my rather long monologue, but I think that these explanations are required because of the complexity and the diversity of services and information provided by Copernicus. I hope it wasn't too long and too boring, but now I guess you will have quite a lot of questions, and I'm obviously at your disposal to answer them.
Excellent, Stefan. Thank you so much about this presentation, which was not boring at all. Quite the opposite. It was very interesting. I think you have succeeded in explaining your friend's mother what Copernicus is doing, but it takes about an hour or so. It does so much stuff.
Yes.
It is actually not only the European Union, it is humanity's eyes to the skies. It is our big eyes to the skies.
It's funded, and I forgot to say it, and thank you for giving me that opportunity. It's paid by the European Union, managed by the European Commission, but it serves the planet as a planet and the citizens of the planet, because the air quality information, for instance, we deliver is not only over Europe because we are egocentric Europeans. No, it's available. The same data is available over Japan, over Brazil, over the United States, over wherever. And you know what? You know how all this costs?
I presume quite a lot.
€2 per EU citizen per year. Less than a coffee in most EU member states' capitals. Less than a coffee per European citizen. So that's, again, is amazing, because when you think of everything it does for the price of a coffee for each one of us, I think it's, again, a good use of your and my taxpayers' money.
And also, it is an example of how a service to the world can provide with accurate solutions to the Metacrisis, because we're here on the podcast on the Metacrisis. And what I wanted to ask you is, as you are working quite 2 decades now in Copernicus, you have seen it from the start, and it does so much stuff. Dealing with data during these last 2 decades, and seeing climate change, seeing soil depletion, seeing coral reef destruction, how does that make you feel? How does that, I don't know, you personally, your co-workers, your people, the people that you are meeting every day?
I'll make 2 remarks. One, over the past 20 years, we've seen an incredible evolution of technology. When I started in this business, satellite images were traveling on huge magnetic tapes. It took days before you got the data. Now it's 2 to 3 hours after the satellite has acquired the images. It's available in the cloud on my computer. The resolution has improved. With the cloud and the high power computing, we can now do things with these images and have huge, to give you the Copernicus, it was 3 years ago, so it's worse now, or it's higher. 3 years ago, I heard that if you take all the data from the Copernicus Sentinels and put them in old style CD-ROMs, it would make 2 piles as high as Big Ben. So it's a lot of data. So in the past, even if we had such an amount of data, we wouldn't have known what to do with it. Now with cloud, high power computing, artificial intelligence, we're able to make sense out of that data. So these two revolutions, the digital revolution is also kind of helping the development of Copernicus. How would I feel about it? Well, I feel alarmed because, especially in my position, I get this information as a scoop before it gets released. And it really is getting obviously worse. I'm proud that the European Union has launched this, and I very modestly, very, very smallly, in a very small fashion, contributed to its development. I still feel passionate as I was the first day, even more because now, when I started, there were no satellites flying. None of our satellites were flying. The services were being developed. Now I see the benefits. And when I see the Washington Post using a satellite image from Copernicus to illustrate some situation in America or elsewhere, I'm proud, I'm passionate. And in fact, that's one of the criteria when we hire colleagues. The first criteria is passion, because this is not only and not firstly a job. That's a mission. We have a mission to promote this incredible program that has so many benefits, and especially with the climate crisis, it's obvious that it's needed, and it's, again, not only as a job as a company, but it's as a human being.
Yes, well, I see that Copernicus is contributing to the diagnosis and to the prognosis of the situation.
And to the mitigation.
What about the cure? Do you feel optimism or pessimism? Where are you? This is this number that is going around these days. Your P-doom. Do you have a possibility of doom?
That I cannot say, because we are not. We just what is also exceptional about Copernicus is the amazing amounts of science that have gone and still go into the production of the services and everything. So we can only tell about facts, and we can only tell about if the curve continues in the same way, this is where we're going. So the mitigation measures are not in the realm of Copernicus. Copernicus can support a lot of them. I mean, the transition to renewable energy, the Repower EU plan, this can be supported by open data that is used by developers to optimize the location and structure of renewable energy power plants. There's many areas where the Green Deal, there's many activities of the Green Deal that can be supported by either Copernicus, but also Galileo data. If you have better positioning, you have better guidance, and you take a shorter route, and you use less, today less fuel, tomorrow even less electricity, because at the end of the day, you need the fuel to produce that electricity. So we cannot deal with the cure at Copernicus level. We can support the measures that the European Union and or the citizens at their scale put together to try and mitigate the situation and hopefully reverse the trend. But Copernicus doesn't have the cure.
Yes, of course it doesn't. What I'm asking is if you see that we are coping it with the problem in a fashion that would suggest that the data are useful, because right now we have a lot of data, we have a lot of science, we know the situation. What I'm worried about is that we don't need more data to make sense of the situation. We know it quite well. What I see that we are lacking at the European and also at the global level is the political will to act upon the data.
That's something that goes beyond Copernicus.
Yes, of course it goes beyond.
As a private individual, what I can say is to make informed decision, you need people to understand the problem. You need to show that this is science. This is not things invented to promote some particular policy or whatever. Then you need policies, and the policies have to be global. And at least another benefit of the European Union is we have decided altogether to do the Green Deal. We have decided altogether to do the Repower EU. We have decided altogether to protect forest, biodiversity, etc., etc. So that's definitely part of the cure. And then Copernicus is helping the implementation. So whether these measures will be fully implemented, not for me to say. Whether they will be sufficient, not for me to say, but for sure, contributing to the understanding, but more than anything to the awareness. When you see the figures, well, maybe you start really putting the plastic in one bag and the paper in another one, and maybe you consider buying an electric car. I mean, I don't own a car anymore, and when I rent a vehicle, I rent an electric vehicle, and I refuse to use any when I can do it. Even when I can rent a car. I came here. I'm in southern Spain right now on business. I rented an electric car. So, but that's also because I have now the awareness of the acuteness of the climate crisis, and I try to do something at my very modest level. And I hope that the more of us do that, the more there's a chance that our grandchildren won't be drinking wine made in Finland, and that a lot of places that we know are completely deserted because of desertification.
Do you deliver this kind of speeches to schools, to school children? Do you have a program in order to educate young children of today?
Well, yes and no. Individually, my colleagues of the EU Space Support Office, with the various languages that they speak, and our colleagues of the European Commission, we try to respond to requests from schools. I was recently speaking to a school that did a cup for youngsters, like COP27, and I went to their closing ceremony, etc. But we are at the EU Space Support Office we're finalizing the development of an educational kit that will be downloadable online in all the EU languages, with the exception possibly of Gaelic and Maltese, which are, I mean, in those countries, they all speak English anyway, in Malta and in Ireland. So we are going to do things that the professors, the teachers will be able to download. They will have tutorial videos, they will have the quiz, they just have to print it, they will have all the explanations. And the ultimate objective is not to promote Copernicus. To promote Copernicus for the sake of what? Of just saying, oh, we're doing a good job. No, to promote Copernicus as a tool for understanding our environment and hopefully better protecting it.
Yes, exactly. No, I believe that without youngsters, we cannot really hope for the future. So let us
go to Costa Rica. I went there for work, and I drove around 1,000 kilometers. I stayed 3 more days to try and see the country. I didn't see one bottle of plastic, not one. I went to 3 or 4 different areas along the sea. The only thing I saw that I can call pollution was the closing lid of a plastic bottle. Not even one plastic bottle, just one lid on the sand. That's all I saw. And when I discussed with the Costa Ricans, they said, well, there's very stringent laws. You really get in big trouble and pay big fines if you pollute. But we start at kindergarten. We start at kindergarten teaching the very young ones about how to manage waste, not to throw things into the environment, blah, blah, blah. So
that's why I believe that this kit that you are talking about is really essential. We should start at the school level. The sooner, the better.
Yep, definitely.
I don't believe that the older generations, my generation, your generation, are going to do the difference. We do not change that easily. Our habits, our daily lives.
Right now, we're trying to slow the process, but it's like a very big tanker on the sea.
It's like a very big tanker.
If you turn the wheel, it will take some time before it makes a U-turn, or before it stops. It has a lot of inertia. So yes, we need to reverse the course, and hope for our children and grandchildren, in my case, to be the ones that will be hopefully benefiting from stabilization of the phenomenon.
So let's close our discussion with something positive. Should you have to give one advice to the youngsters of today, how would you suggest that they should use the data you provide them with from Copernicus in order to create a lifestyle, in order to design a lifestyle? What is the essential part of Copernicus data they could use in order to design their lives?
For youngsters, I don't think they can really use Copernicus to design their own lifestyle. It's mainly at their level an awareness raising tool, which will make them conscious that the lakes and the reservoirs are depleting, the trees are disappearing, the bees and the pollinators are disappearing. So it all starts by conscience. So they should mainly use it as a tool to develop consciousness of the acuteness of the crisis. I would say it's maybe Galileo, because it's a thing you have in your phone and you carry, is maybe more directly impacting your lifestyle, because when you do sports and you know how many meters you did, whatever, this is Galileo. There's many things that really impact your day-to-day life, while Copernicus will only impact, again, looking at the pollution in 4 days or the risk of forest fire. It's not your lifestyle. It's more how you deal with things you're allergic to or dangers that you're potentially exposed to.
Thank you, Stephane. This was a very interesting discussion, a discussion that I particularly enjoyed.
My
Keep
pleasure.
up the great work. We all need it. And whenever you have something more to say to us, please consider this podcast your podcast.
I will. Thank you so much for your time, and it was a pleasure talking to you and to your listeners.
Thank you, Stephane.
Thank you.
Let's
Bye-bye.
talk again soon. Bye.
Yes.
Thank you for your time. So this was my conversation with Stephane Ourevitch, a leading professional in the space data science, representing Copernicus, who is the leading institution when it comes to bringing awareness to the world. It is our eyes to the skies concerning our little beautiful home. I hope you enjoyed our conversation. Stay tuned, for there are other conversations coming. Send me your thoughts, your ideas, your feelings. See you at the next History of the Metacrisis. Bye for now.